Alright, today we're going to learn how to graph systems of equations. So we will graph them to determine whether the solution is one, infinite, or no solution. A system of equations is two or more equations. You will get a no solution when the lines are parallel, and to be parallel it means they never intersect. The equations will then have the same slope but different intercepts. You will get one solution when the two lines intersect at exactly 1 point. And if you get one solution, you will be asked to identify that 1 point where they intersect. You know that you'll get two different lines and they intersect at 1 point if the slopes are different in both of the lines. An infinite solution is where you will have a line and then another line will be graphed, and it will graph as exactly the same line. This will occur when the two lines have the same slope and intercept. To graph a system of equations, we have some steps. The first thing that you will do is solve for y. If there is no y, then you will solve for x. Your second step is to identify the slope and intercept to graph the first line. Step 3, you're going to identify the slope and the y-intercept to graph the second line. Step 4, once you have both of the lines graphed, you will identify the solution either as one solution if the lines intersect, no solution if the lines are parallel, or infinite solutions if they are the same line. And you can show this by 1, and then you'll list the ordered pair. You can write no solution if they don't intersect, or you can do that sideways 8, infinite solutions if they're the same line. So here's our first example. We're going to graph and then decide what the solution is. So with this one, because we have y all by itself on the first line, we will go ahead and graph up 2. And because it's just y, every value of y has to be 2. So that first one has been graphed. We'll graph the second line first by solving for y. So to solve for y, the first thing you do is subtract x. You want to get y all by itself. So these subtract out, you're left with 2y equals, and I always put the x first, so negative x plus 2. And then from here you'll divide every piece by 2. So you're left with y equals negative 1/2 x plus 1. Once you have y solved for, then you can pick out those important pieces like the slope. The slope is negative 1/2 and the y-intercept is 1. So we will use that information to graph. This says that we start at 1 and we go down 1 over 2 or go up 1 over 2. And I would encourage you to keep graphing that slope until you can decide whether those lines are going to intersect. We can see here that these two lines intersect right there at that point. And so we will say that there is one solution. I'm going to write it above. And it's located at negative 2, 2. Okay, we'll do another example of this. This is a case where x is all by itself, or it isn't all by itself, but it's the only variable. So if there is no y, we solve for x, and to solve for x, we divide by 3. So this gives us an equation here, x equals negative 2. So to graph that, we go back 2, and then we create a vertical line. Oh, I missed. And then you look at the second equation, and we tell ourselves that we got to solve for y. So to solve for y, you subtract 4x from both sides. These 4x's subtract out. You're left with y equals negative 4x. I put that first, minus 2. And then from here, you pick out those two important pieces, which are slope. Slope is that value that's next to x, so negative 4, we're going to make it a fraction by putting it over 1. And then your y-intercept is negative 2. It's that piece that follows. Okay, so to graph that, we're going to start with that y-intercept negative 2, and then you need to make sure you apply the slope, which says we go down 4, positive 1, and we can see that direction isn't getting us to the line, so I'm going to go up 4, 1, 2, 3, 4, back 1, apply the negative to the 1, and do it again, up 4, 1, 2, 3, 4, and back 1, until I intersect that line. And then from here you just need to draw that line And notice that right here is where they intersect. We need to identify that. We call that one solution. And I'll write it above again. And it's located at -2, 6. Okay, our last example actually has two equations with two different slopes. So because we can recognize they have different slopes, that means they're going to intersect. So this first one, we want to solve for y, and since y is already all by itself, you can pick out those important pieces like slope. Slope is that value next to x, so it's 2, but we want to make it a fraction. So we put it over 1. Your y-intercept is the piece that follows. Because there's nothing that follows, it's 0. So to graph that, we start at 0, and then we apply that slope up 2 over 1, down 2, back 1, and we draw that line. And you want to be ever so careful when we're graphing these. They need to be exact. If you need to use a ruler or a straight edge, that would be the best. And then our last one, you again want to get this y all by itself. So to get that y all by itself, we're going to add x to both sides. That subtracts out, and we get y equals, again, I list that x first, plus 1. We identify slope. If there is no value in front of that x, we know it to be a 1. So slope is 1. We make it a fraction by putting it over 1. Your y-intercept then is that extra piece at the end. So it's a positive 1. So we start at 1. We apply that slope up 1 over 1, up 1 over 1. You can see that those lines intersect already. We're good to go. So right here is where the two lines intersect. We call that the solution, and we have 1 located at over 1 up 2. Now I didn't show you what it would look like if you had lines that have no solution. So just to recall, a no solution is where you'll get two lines that do not cross. They will end up being parallel. An infinite solution is when you graph the line and then it graphs as the exact same line. So this should take you to your assignment. Your assignment will be the 4-3 graphing systems of equations. I only want you to do the first 8, and then I will teach you some tricks with your calculator when we return. Thanks. Good luck. Bye.